So today we get to answer that question, what is a vector? And even if you've never asked it, we're going to answer it anyway. So to help you out, here's a little video.
Hey. I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah! Check out my new weapon. Piranodon! Oh yes! Fires live piranhas. Ever seen one before? No, you haven't. I invented it. Do you want a demonstration? Oh! Ah! It's so difficult sometimes to get the piranha back inside.
Mr. Brew, Mr. Perkins, you see now.
Vector! And as he said in the film, a vector is a mathematical property that is represented by an arrow that has both direction and magnitude. Oh yeah! Now, as he suggested, what is direction? Direction is obviously, well, direction, you know that one. Magnitude just means size. He's just got an arrow that has a direction and some size to it. So let's look at our first arrow here. Now, we're back to using reflections, rotations, and those sorts of things. You remember what was called translation, which got moving a shape around. When you move the shape, you used a vector to describe that movement. And a vector looked something like this. And the top line told you whether it went right or left. The bottom number was either up or down. Using the same idea, this vector here, you can say is going 2 to the right and going 3 up. The vector down there, because it's going, the arrow is pointing this direction, because starting from there going down to here, we're going this way first, so that's the left direction, which is a negative one. So negative 2, then down 3, so that's negative 3. Now, how do we sort of name these vectors? Well, let's label this A and B, and label this one A and B. We could say this vector here is going from A to B. So we write A, B, and we're going in that direction. Whereas this one, the arrow is going this way. So it starts from B, and it's going along to A. The other way you may see it written is I might just label the line and call it maybe line A, line B. So you can either write it as A with an underline, or sometimes they write it in bold. So big, heavy A, or again B could be B, underline, or a nice big bold B. If you don't have notes on this, we'll make some notes of this in your book, pausing it, just writing this down. Which should leave you in a good place to attempt these questions. Have a go at this in your book and pause it and come back and play it again for the solutions. Now, the key part to this question, okay, so here's our solutions. Here's our vectors describing each line. So A was 2 right and 2 down. B was 3 across and 3 up. And the key point was looking at the link between the column vectors and the parallel lines. Now, A and F are our parallel ones. Now, A was described by the vector 2 minus 2, and f was described by the vector 4 minus 4. If you can see, these parallel lines is merely twice the size of the first one. Times by 2 is 4, times by 2 is negative 4. Which makes sense, because if you look at A and our F, there's the size of A, so A is this big, and you can fit 2 of those into the same space as F. So the key you're looking for is the fact there's a multiplier between your 2 parallel lines. It could be 2 times bigger, it could be half the size, but it must be the same multiplier for the top part and the bottom part. So take a minute and answer this question. Are these 2 vectors parallel? Let's check. So how do I get from 3 to 6? So that's times 2, from 2 to 4, times 2, so yes, same multiplier, so they should be parallel. We can double check this. Let's draw this 3, 2 vector. So if I start here, going across 3, up 2. And the vector here, I go across 6, 1, 2, 3, 4, 5, 6, up 4, 1, 2, 3, 4. And without a ruler, very bad of me. See, those two are in fact parallel. Different magnitudes, different sizes, but the same direction. Right, here's your quick challenge. Match up the parallel vectors in 20 seconds. Go. Ten seconds left. And 5, 4, 3, 2, 1. Stop there. So, you should have found that your matching pairs were as follows. So there are solutions. So look at these 2 here. Now we could say that either it's a multiplier of a half going that way, or that's a multiplier of 2 going the other direction. Either way, it's got the same multiplier. Now, the same thing applies when vectors are written out in their letter form, like this. Matching up the parallel vectors. Let me show you one as an example. See if I can find ones to match up. Okay, so if we look at this one and this one. If I take 2c plus b and I multiply both of them by 3, I'm going to get 3 times 2c is 6c, 3 times b is plus 3b, which is this one here. So we know that this line and this line are parallel. I want you to pause the video and match up the rest of the parallel vectors. Write them down in your book. So here are your solutions. So 2a and 2b match up with a and b. Your 3c and 3b match up to c and b. Now minus 2b goes with the minus b there. And then all 3 of these are parallel. Because all this is negative, so we've got a 2a go, say this is 2a, and this is a. The minus 3a is 3 times bigger than this, to 3, it's just going the other direction. Now, vectors are much like paths. Okay, here's 2 paths, path A and path B. Now, we can join them together, like this. And we've got this little vector here. You can walk up path A and down path B. Now, if you drew a line across there, although we're not told a vector for this line, because here to get from, say, A to B, so along this line here, it's the same effect as going up A and down B. So you can describe this A to B vector as the A plus the B. Let's look at some bigger pathways. Now, we're told here we've got vector B, which is actually this one here. That's a B. And this one here is called an A. Let's just do it like this. Now, if we want to go from A to B, so from A up to B, you can see we're quite simply going along the A scenario. From B to A is going backwards. Because going backwards, we're going the opposite direction, make it a negative. So that's going to be a negative version of our A. A to C, what do you think it is? Up to B first, so using A, then following B down to C. So plus vector B. Now C to A, there to there, is again going in reverse. So it's going from C, we're going backwards along B, and then backwards along A. Now our last scenario is going from B to D. There's two ways to go along this path. You either go down this path and along that one, or we can go down this path and along that one. So let's go B to D this direction, the green direction first. So this bit down there is quite simple. There's our B again. Now this part, well, what is it? If you see here, these two lines are parallel, and therefore this is also going to be A in that direction. So it's positive B, then backwards along A, so it's negative A. In the pink direction, so first of all you're backwards along A. Again, you've got those parallel lines, so that's the same as B. And we're going along B in the forward direction, so plus B. So those two, no matter which way we go, is exactly the same thing. If you want to be really fancy, you can do some really convoluted routes like this way, then that way, then that way. And you should still get the same answer. Well, let's check that. So B to A is backwards along A, so it's been negative A. A to C, well, earlier we found it was positive A and positive B. And C to D is that negative A. Let's have a quick look. So we've got a negative A, plus A, minus A. So it's minus and a plus is 0. So it's minus A left over, plus B. And look, once again, it's exactly the same. No matter which path you take, you get the same solution. That is a really quick run through of the basic principles of vectors. Have a go at the set questions, and then come back, watch it through, pause it as you need, or use a book to help you answer the questions that are being set. Oh yeah!